Assalamu alaikum. So today we are going to be showing our DS project, which is called Point of Sales. And our group members are Ahmar Ayaz, Hasan Ali Vejlani, and me myself, Mohammad Ammar. So Point of Sale is a checkout system that loads inventory to a hash table and gives recommendations to the customers based on the graph structure, which is created according to historic customer purchases. So first of all, the motivation was to increase the sales of a store when when a customer is supposed to check out and he is emptying his cart. He's always recommended certain products that were earlier purchased by other users, which would help him and help him make decisions of his own grocery products that he needs to take. And this was the main motivation behind it. So first of all, we would be initiating a store, and to initiate the store, we are taking some fake data, which is taken from the website called Mockaroo. So in Mockaroo, we just need to define a few fields, and for in our case, since we are generating an inventory-based data, we're first of all taking an ID, a name, price field, and the quantity field. All of their types are defined over here. And after the data was generated, a CSV file was provided. In this example, we can see the mock data that we are using. Around 1,000 rows were generated, and that's what was fed into the hash table. So coming back to the presentation, after the initiation of the hash table, we went off to populate the graph data structure. And while the hash table was being populated, we can look at the product table itself. Its size was initiated to be 1/3 more than the size that we had provided the hash table, which was of 1,000 rows. So around 1,360 rows were created in that hash table, and that's how data was inserted. Since the data was fully linear and was in an ascending form, so there were no collisions, but to accommodate collisions and custom product IDs, we had allowed linear probing and quadratic probing to fully accommodate all the data, and using various hash functions, we were able to accomplish this. So while searching the data from the hash table, we are also doing the same thing, but in a reverse format. So the data could use the same rehash functions until a key is matched, and our items can be easily get. So the big O of the whole procedure for using the hash table is going to be order of 1. So now we come to the graph data structure, which is going to be explained by Ammar.
So in the graph data structure, we basically pass the product table, and from that we initialize a vertex table, so that in the graph data structure we can directly access each vertex using its product ID. And when the graph data structure is initialized, we we pass every product's ID, and for every vertex we make, we add an edge to it. Since we don't have any previous customer data, therefore we for the presentation we are adding fake edges to every vertex based on as you can see, these are the products. And now this is how the graph is actually represented. So every vertex is connected to another vertex, and all of the edges which they are connected with are weighted edges. So what happens is that when we recommend the products, the top 5 products to a person, we do this based on the weighted edges of each vertex. And in the edges class, we are storing the destination of the vertex from which this edge passes to, as well as the weight of this edge. So we increment the weight whenever an edge is created between the vertex, when the person adds it to his cart. And in the vertex class, we have a priority queue of edges. So what basically happens is that the top five edges of that vertex, as in the top 5 vertexes it is connected to, which it has the highest weight with, it will return these vertexes. And when we return these vertexes to the graph will find out the product IDs and will return these to the customers when he is in the cart, so that he can get 5 recommendations of products to buy, which will be based on the product he last put in his cart. And here is how the recommendation system works. The top 5 edges are returned, and through this we get the top 5 vertices ID, and from the vertices ID we get the products ID. And the big O of this is order 1, since this is based on the hashes, and in the vertex table we access them directly through the hash of the ID of the vertex. And now Hassan will explain the GUI.
So over here we can see the GUI. On the top we have the item ID and the quantity that the person requires. When they press enter, it gets populated in the cart list, and the grand total is displayed below. On the side we have the recommendations that get updated as the items get added, and a complete transaction finishes the checkout. So the elements of the GUI as explained, these are all the elements. Now this is one example. While it is running, you can see that the cart list shows the ID, name, price, quantity, and total of all items, along with the grand total currently. The recommendations are based on the last item added, as previously mentioned, and it gives its ID, the description, and the price of it. When we press the select, it puts the ID into the item ID, and after selecting a quantity, we can enter it. These are some of the dialog boxes that can show up. It checks if the values are correct, and if whether the product exists or not. And on a successful purchase, confirmation box is shown. Now we will be showing you the GUI running. So here we start our code. It is now initialized. So over here we can add an item ID. For example, we are 345 and we take 5 of these items. When we press enter, we get the item, its price, its total, everything is shown. We also get the top 5 recommendation, which is connected with this item. We can add another item, and with its quantity, it gets updated. So let's say we want to add juice to this. So we select this, we get the item ID here. We just need to put the quantity, we enter, and we can keep doing this. And when the person has selected all that he needs, you can press the complete transaction. It will give an affirmation, and it will reset this for the next person. And to check for the other dialog boxes, we can add an invalid ID, for example, 4000. And when we enter this, the product does not exist. And it ensures that if we put something else other than a valid number, item ID and quantity must be integer values.
And these were the resources we referred to, such as we used Java Point for our GUI documentation, and we used Stack Overflow for troubleshooting various errors we faced in our code, and we were able to get our solutions from these to using these two resources. And this will be all from our presentation. Thank you.